Hi, this is Alex from devstories.eu. MicroPython, Episode 1 of 7. Desktop Python normally consumes megabytes of memory just to start up. Try putting that on a tiny $2 chip, and the system immediately runs out of resources. To write Python for microcontrollers, you need an interpreter that fits into a fraction of that space without losing the core language features you rely on. That is exactly what MicroPython provides. MicroPython is a lean, highly efficient implementation of the Python 3 programming language. It is designed specifically to run in constrained environments. Standard Python, often referred to as CPython, assumes it is running on top of a full operating system like Linux or Windows, with gigabytes of storage and ample RAM. MicroPython flips this assumption. It is built to run bare metal. There is no underlying operating system managing the hardware. Instead, MicroPython acts as the operating system. It interfaces directly with the hardware, so you can write high-level scripts to control physical devices. The engineering behind this focuses entirely on severe resource constraints. MicroPython can execute entirely within just 256 kilobytes of compiled code space. Even more impressively, it requires a mere 16 kilobytes of RAM to operate. Within these tight boundaries, it delivers a fully functional Python environment. Standard Python includes a massive standard library, famously known as the batteries included approach. MicroPython strips that down to a carefully chosen subset of modules, keeping only what makes sense for an embedded system. Despite these heavy optimizations, the language itself remains authentic Python 3. This means the code you write on your desktop translates directly to the embedded device. MicroPython supports advanced language features like closures, list comprehensions, generators, and standard exception handling. It even handles arbitrary precision integers. If your logic requires multiplying massive numbers, MicroPython scales the memory dynamically to give you the correct answer without crashing into a hard architectural limit, exactly like desktop Python. Here is the key insight. Because the entire Python engine fits onto the chip, you get a live interactive prompt directly on the hardware. This read-eval-print loop changes how you write embedded code. Normally, programming a microcontroller involves writing code in C, compiling it on your desktop, flashing it to the board, and waiting for it to run. With MicroPython, you plug the board into your computer, open a serial terminal, and type Python commands directly into the chip. You can test logic, read sensor values, or trigger actions instantly. To make this possible, MicroPython includes specific built-in modules that go beyond standard Python. Since standard Python knows nothing about reading physical pins or configuring hardware timers, MicroPython provides specialized, highly optimized interfaces for these tasks. These are built directly into the firmware for your specific chip, giving you raw control over the physical world without bloating the memory footprint. By stripping away the operating system and shrinking the interpreter to fit in 256 kilobytes of compiled code space, MicroPython turns cheap, resource-starved hardware into a dynamic, interactive development environment. If you want to support the show, you can find us by searching for DevStoriesEU on Patreon. Thanks for tuning in. Until next time.